Hi, I'm Professor Andy Field. I'm Professor of Child Psychopathology and I teach research methods and statistics in the School of Psychology at the University of Sussex. Learning about statistics at the University of Sussex is really not as scary as you might imagine. So in psychology, for example, we don't assume that anyone coming onto our degree programme has any prior experience of statistics, and really we're geared up to teaching you from first principles and just assuming basically you know nothing, and we're going to teach you everything that you need to know. We also have a lot of good support mechanisms in place. So the typical structure of the teaching is you'll have a lecture from someone like me, a member of faculty, and then they're supported by lab classes where you'll be taught by postgraduate tutors. So even if you find the idea of being taught by a professor kind of scary, which it's obviously not, because we're just normal, well, relatively. Our postgrad tutors are, they're only a couple of years older than you. Some of them have been through our degree programme before and they're now doing further study. And they're really nice, friendly people. They can really empathise with the fact that you might be a bit scared about doing statistics, and they'll give you lots and lots of support. We also have a mentoring scheme as well. So in your second year, for example, you can apply to be a mentor of the new first year students in research methods and statistics. And the role of the mentors is very much, again, to offer support to any students who are struggling, and just to really be a body of people who can say, well, we did this, it's possible to do, we got good marks, it's all going to be fine, have a cup of tea, chat about what you're going to do, and hopefully not give you the answers to the coursework. One of the things that I think psychology students are most surprised about coming into their degree is the fact that they have to learn statistics. Especially if you haven't done A-level psychology, your perception of psychology as a subject is probably that it's not a scientific subject, and to be frank, people sometimes think that psychology is all about laying on a couch and talking about your mother or something like that. But actually, psychology is a scientific discipline, and we take the scientific element of it very seriously. So all of the courses that you do are based on evaluating evidence, being able to collect data about a question that you might want to answer, and then drawing conclusions about what's going on. So the whole of psychology is based on statistics, research methods, doing experiments, testing out theories. So essentially your statistics and research methods course it's the spine of the subject, it's the spine of psychology, it's the central nervous system, and every other topic in psychology stems from that basic core subject. So you cannot learn about cognitive psychology, for example, without knowing how to conduct experiments, without knowing how to test theories. You can't understand social psychology also without knowing how to test the theories you have. If you want to know why crowds behave differently to individuals, you have to put that to the test, collect data, do an analysis on the data, and then draw conclusions. So really, research methods and statistics is absolutely fundamental to the subject of psychology. You can't understand anything about human behaviour without knowing about statistics and research methods. The way to do well on your statistics course is essentially just to practice. So nothing that we teach is fundamentally that difficult, and nowadays, if you were learning about statistics 50 years ago, you'd all be sitting there, with an abacus or a piece of paper or something, doing all these horrible hand calculations. But now we have nice computer software that does all this, or basically does all the hard stuff for you. So it's more about interpretation and just looking at different examples and seeing how you apply statistical methods in different situations, and then how you interpret the results. So there's nothing fundamentally that hard about it. And one of the things I think is really good about statistics, especially if you're studying it in a different discipline like biology or psychology or something like that, is it's really a topic where there's no there's no reason at all why you can't get 100% on a statistics paper. If the answer is right, the answer is right. You get the full marks. It's not like writing an essay where there's potentially some subjective judgment about what you've said. The answer is the answer. So, I think in a way, statistics is a topic you should embrace as one that you can do very well on. And many students get their best marks in research methods and statistics, much to their absolute amazement, because often when they come into the course, they would probably think that would be their worst subject, and it turns out to be their best subject. The way to get those good marks is, as I said before, really simple. It's just practice, practice, practice. It really is a case of practice makes perfect, and we provide lots and lots of different examples that you can use. I have a website, for example, that has podcasts and demonstrations and data sets and a whole world of resources that help you to just practice using the skills that you've learnt in your lectures and your lab classes. But also generally at the University of Sussex, we're quite committed to e-learning. We have Study Direct sites, which is a learning environment, and many other lecturers, not just me, will have resources on these sites, data sets, practice examples. So basically you have every opportunity to really try things out. If you don't understand them, go back to your tutors in the seminars and say, well, I was all right with this question, didn't quite understand this one, and work through it. And you will all do extremely well, I'm sure. I think one of the interesting things about statistics that people don't necessarily immediately think of is that it's quite an important transferable skill. Because if you look at any newspaper, any TV broadcast, the news, everything really, they're always throwing numbers at you or throwing facts at you, and often throwing science at you. Scientists have discovered this, that and the other. And by learning about research methods and statistics, you are in a great position, a position that many other people in the world are not in, which is to evaluate that evidence, to be able to use your critical faculties that you've developed over your degree to actually say, well, is that right, or are the media spinning me a line? And, well, this is a slightly trivial example, but I was, at the time we're filming this, the World Cup, the Football World Cup has just stopped, and there's been lots and lots of stuff in the press about Paul, the octopus, who allegedly can predict very reliably the results of games. So this octopus was predicting various matches by essentially kind of wafting over to a food tray. He had two food trays. They'd put the flags of the two countries in the match on the food trays, and he would kind of swim along to one of the boxes, and that was his prediction. Now, arguably, he just had two boxes of food, and he was just swimming over to one of them. But the fact is, he kept getting the answers right. So he kept feeding from the box with the flag on of the team that won the game. And the press were making a big deal about, the clairvoyant octopus. The octopus can tell the future, he can predict matches. Presumably the octopus is going to swim off to the betting shop and earn millions of pounds with his clairvoyancy. But the fact is, there was never any real data. There was never any evidence presented that his predictions were any more than you might expect by chance. Now, as someone who's studied even very basic statistics as part of your psychology course or your medical degree, whatever course you're on, you're in a unique position in that if you even know a little bit of information, just how many matches he got correct and how many matches he didn't correctly predict, then you can basically ascertain statistically whether his predictions were more than you would expect if you were guessing. So if he was just randomly going to a food bowl, how often would he get the answer right versus how often he actually got the answer right? It's a very simple test you can do, and you would then know, well, are the media just getting a bit excited about this, or does the octopus actually have the power to predict football games? Now, obviously, being a bit of a saddo, I've done this. I know the answer to the question, but I'm not going to tell you unless you come to my lectures.